One theory advanced by the clods on the internet is that my reaction is just aluminum and sodium hydroxide, a conventional chemical reaction. But we all know that aluminum is instantly consumed practically when you dip it in. It's a bit like throwing sodium into water. So if that's sodium hydroxide reacting to aluminum, this thing should be pretty much eaten away in seconds. Let's see if that's the case. In goes the water. Now we can see there's plenty of hydrogen bubbles being created by the reaction. If you look there, there's the aluminum piece of rod, and it's creating a lot of nice little fine bubbles. Very small, very fine bubbles bubbling up from the aluminum. Some larger bubbles surrounding it. But if you notice, right at the very ends, mostly the end of the rod where I had dipped it into the catalyst, is where all the tiny little bubbles are coming up. They're coming up in a rather large stream. It's almost like a column of fine bubbles coming up from the end of that where I dipped it into the catalyst. Now notice the other end of the aluminum doesn't seem to be reacting very much. It's reacting a little because of course the catalyst is dispersed in the water. And you're still seeing it, but you're not seeing the hydrogen bubbles that come up here in the fine stream from the end of the aluminum catalyst where I dipped in the white pigment. The reason for this is because the catalyst is not sodium hydroxide. It's titanium dioxide, graphene, and hematene. And it reacts the aluminum slower, but it reacts it at a fairly constant rate and very well.